Biosensor from Group 7. Outlines for this video. Introduction. First generation biosensor. Second generation biosensor. Third generation biosensor. Recent advance. And conclusion. Introduction. What is biosensor? Biosensor is a sensing device comprised of a combination of a specific biological element and a transducer. Specific biological element recognizes a specific analyte, and the changes in the biomolecule are usually converted into an electric signal by a transducer. It detects, records and transmits information regarding a physiological change or process. Example of bioelement are enzyme, antibody, organelle, DNA, microorganism, and cell. There are 3 generations of biosensor. The first generation biosensors are the oxygen-based electrodes. It was first described by Clark and Lyons in the year 1962. It's used for the determination of glucose and uses oxygen as the oxidizing agent. But how does it work? In the presence of glucose oxidase, glucose is oxidized into gluconic acid and FAD is reduced to FADH2. FADH2 then reduces oxygen into hydrogen peroxide, whereas it's self-oxidized into FAD. The hydrogen peroxide is then released in the air. After the glucose and oxygen react with the glucose oxidase to form gluconic acid, only the oxygen remaining will penetrate the second membrane of biosensor to be measured by the electrode. This will produce electric current. Higher electric current reading indicates higher concentration of glucose that present in the sample. Then, second generation biosensor are the improvement of first generation biosensor. These improvements were achieved by replacing oxygen with electron redox mediators that were able to carry electrons from the enzyme to the surface of the working electrode. Example of mediator is ferrocene. Ferrocene is reduced mediator. It will react with the enzyme on the electrodes to conversion glucose to gluconic acid. This converting process oxidize the FADH2 to become an FADH and producing ferrocenium ion with 2 electron. The production of ferrocenium ion with 2 are be able in detecting current signal. The lower potential of chosen mediator, 0 to 2 volts, results in no interference from other electroactives such as uric acid and ascorbic acid. This redox mediator enhances the electron transfer between the redox center of enzyme and the electrode surface. Next, third generation biosensor. Third generation biosensor is an improvement of second generation biosensor. In this generation, redox mediator are not used. This generation involves the direct electrons transfer between the active site of the enzyme and the electrode. So how it's work? The whole reaction process can be divided into 5 main stages. The first stage involves the binding of glucose to the active site of glucose oxidase, whereby the glucose oxidase will catalyze the formation of gluconic acid, and at the same time, electrons are released. During stage 2, redox reaction will occur at the FAD/FAD2 redox cofactor in the active site of the glucose oxidase. After that, at stage 3, the electrons are transferred from the enzyme to the electrode. Later, the electrons are passed from the electrode to the transducer, and finally, the electrical signal is produced. Recent advance. Sensor is important in medicine and life sciences to monitor vital and diagnose patients. However, novel sensors have been developed due to the need for early detection and diagnosis of disease. For example, application of nanomaterial is a fabricated nanosensor. Nanomaterial used for nanosensor fabrication are graphene and graphene-based nanomaterial. What is graphene? Graphene is thinnest than paper but strongest than steel nanomaterial with single layer of carbon atom, and it is a superb conductor. Graphene is used as transducer of biosensor. It converts the interaction between the receptor and target molecule into detectable measurement. For this to occur, the bioreceptor molecules such as antibodies, single-strand DNA, and enzymes needs to be attached to the transducer surface. The most common attachment method used for antibodies and single-strand DNA mobilization onto graphene and its derivatives such as graphene oxide and reduced graphene oxide is EDC or NHS chemistry. While enzymes are most commonly immobilized using physisorption or physical adsorption. In clinical application, graphene-based biosensor are used for antibody nanosensor with graphene were developed to detect E. coli and Zika virus. Besides, graphene oxide has been employed for the detection of dengue virus, rotavirus and cardiovascular diseases. In conclusion, first generation biosensor oxygen are used as oxidizing agent, while in second generation oxygen are replaced with redox mediator. Then, in third generation biosensor involves the direct electrons transfer between the active site of the enzyme and the electrode. And lastly, in recent advance, graphene is used as transducer of biosensor.